All right. Should we start with the prep?
Sure.
Yeah, that's fine.
All right. Oh, quick question. Does anyone have the applet link? I couldn't find it.
It's on, if you open group meeting, it's on the top of the page again.
Open up what?
If you open up the group meeting quiz, it's right, there's a link to it before question 3.
Oh, sweet. Well, I'm
Is that on the quiz?
What was that?
You said it's on the quiz?
Yeah, if you open up the quiz right before question 3, it leaves it again in the past.
Oh.
all right. Well, then I will not worry about that anymore. All right. So we are on the prep assignment. I was good on this prep assignment. What about everyone else?
This was better than the one earlier in the week.
I'm okay.
I'm okay for now.
All right. Then should we start doing the quiz and then see how far we get? Or I guess let's just start doing the quiz. Don't listen to me. It's been a long day at work.
Oh, it's been a long Monday.
Okay.
Alright. Alright. I can read again if you guys would like.
Yep.
That's fine. You're so good at it.
You know, I work hard. Alright, is everyone ready to start the quiz?
Hold on a second. Still, my internet is a little slow again. Not as bad as the other day, but okay, I got it.
Alright. So, number 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to 3 decimal places. Alright, so using the normal probability applet, I got 0.1745, rounded would be 0.175.
Yep. Right.
Okay. Number 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population?
You know, this one I wasn't sure. I don't know. I think it cannot be determined.
One sec, I'm gonna look in the book and see if there's something that it says.
Yeah, there was something in the book that caught my eye on that. I was trying to find it.
Just from my deduction, which this isn't based on the book or anything, so just letting you guys know. I would think it'd be the distribution of the sample means, because at that point you're finding the sample means of the population, right? So then wouldn't it be closer together than just the distribution of the individual observations in general? I don't know. That's just my thought process.
But do we have we don't know. It only calls for 9 observations. But do we know the population?
I don't think we know the population, no.
So I think it would be distribution of sample means, like you said, because individual observations that could be spread out pretty far. So start taking more, then they're going to be closer and closer together. So I think it would be the second one.
No, it sounded like you were about to say something.
Yeah, I lost something. I'll be right there.
All right.
Okay, so Sean,
I
you
did-
say it's the distribution of the sample mean.
Well, I think it's either that one or it cannot be determined.
Yeah.
Because I'm running through scenarios in my head at 1,000,000 miles an hour, and I can come up with scenarios for both where they could both be true. So that's why I'm thinking it's more likely that it cannot be determined from the information. But
Yeah, that's what I thought.
yeah, but once again, I'm not sure.
Any ideas?
Yeah, I'm reading in the book under section 3. Where example, figure it out here.
I mean, do we even have enough data to?
Maybe like the quiz last night, if we move on, it will help us out with the answer. Or not last night, 2 nights ago.
That's what I'm thinking, because looking at number 5, it kind of forces us to answer number 4. Like it's basically asking the same thing. Which of the following results implies that the spread in the X bar increases as the sample size increases? But it kind of feel like it's asking the same thing for number 5.
I'm sorry, probably my internet is slow, but I can't understand you.
I was having a hard time too.
Yeah, I'm not sure who was talking, but I couldn't understand anything.
That would
So,
put number
okay.
5 would be the central limit theorem, correct?
Right. Correct.
That's what I was thinking, yes.
That's what I remember reading. Does everyone agree with that, or is that just
Yeah.
okay?
Yeah.
All right. Well, let's move on from 4. For me, right now, I have this cannot be determined from the information given, and number 5, I have the central limit theorem. Let's move on and see if we can, get a little bit of help with that, or with those, or I guess with number 4. All right, number 6. So information, use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Diane earns a score of 160. What is the z-score corresponding to Diane's score? Round your answer to 3 decimal places.
So I got 1.045. Is it? 3 decimal? Yeah. 1.045.
1.045.
Yeah, that's what I had too. .04545.
So 160 minus 150.8 divided by the standard deviation of 8.8. Makes sense.
So is that what we're saying? 1.045?
Yeah.
Rebecca, you kind of look confused. Okay, just making sure. All right. Number 7.
Mike, are you okay?
What was that, Chris?
Okay, was okay.
Oh, yeah, I'm good. I'm good.
All right. So number 7. What is the probability that a randomly selected student will score above a 160 on the quantitative portion of the GRE? Round your answer to 3 decimal places. So we got 1.045 for the Z-score, right?
Yeah.
So I
We
put
plug
it
that
in
into the
the
probability output.
and
I got 0.148.
trying one.
Yeah, that's what I had.
Yeah.
Yeah, same.
Yep.
Okay. Number 8. A sample of 5, or a random sample of 5 students was selected to take. I'm really struggling. Take the GRE. Their scores are 160, 175, 163, 149, 153. What's the Z-score corresponding to the sample mean of these student scores? All right. So first off, let's find the mean of these.
So we add them all together
Once-
and divide by 5.
Yes. And I got 160. Is that what everybody else got?
That's what I got.
Okay, so that means their Z-score would still be 1.045 again.
Yep.
And then number 9 is number 7, the exact same question.
Wait, hold on a second. What's this? Okay, what's the answer for number 8?
1.045. Because the mean of the sample is still 160, so it's the same.
Yep. At least that's what I'm getting.
That's what I'm getting. 800 divided by 5 is 160.
Yeah, same.
But it's the z corresponding to the sample mean.
Right, so the sample is the 5 numbers that were given?
Yeah, the sample mean. So wouldn't be hold on.
So the sample
Would
are
be
the 5.
the z-score for the
Sorry, Chris, I didn't hear all that. I cut you off halfway through, which is my fault, but I didn't hear all that.
Oh no, hold on a second. Okay,
Oh, it's right there.
okay, so if we we found the mean, but wouldn't be like 160.8 divided by the 8.8 divided by the square root of 5.
Oh, wait a minute, you might be right.
Because this is not a normal z-score.
Oh,
It's a
yeah,
z-score
okay.
of the
Oh, you're right.
Okay, so it's 160 minus 150.8 divided by
8.8 divided by the square
Yeah.
root of 5,
Okay.
which it comes to, hold on, I got 2.338.
Give me 1 minute to double check everything that I've done, and I can tell you what I got. Ooh, I did that wrong.
Do you had an error on your calculator?
I got like 121, and I knew that that was wrong.
Oh, if you use parentheses, so you do open parentheses, 160 minus 150.8 close parentheses divided by open parentheses 8.8 divided by square root of 5 and then close parentheses. So the order of operation should be correct, I guess.
Did you get 2.337?
338, I
Yeah.
rounded up. Okay.
Okay, I did that on my phone calculator. I'm surprised I got that right.
Yeah, that's what I'm using.
All right. Does everyone get how we got that?
Yeah, I got it.
This was for number 8, right?
Yes.
Do we agree on that? It's not just a normal Z-score?
I agree.
Yeah.
Okay.
And we
So I
got
got
2.33.
2.338.
Yes. Which makes number 9 0.097, rounded would be 0.010.
0.010.
Yes, because you have to round the 0.097 up, and it'd be 0.01.
I think we should leave it.
Oh, it says round your answer to 4 decimal places.
0097.
Yeah, sorry, I didn't see that it's rounded to 4 decimal places.
Right.
It's like the teacher knew what the answer was going to be.
So 0.97 is what you're saying?
Yep.
Okay, so we have number.
We're on number
10.
10. It says, use the following information to answer the next 5 questions. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of students of n equals 81 students will be drawn. Wait, I read that wrong, but you guys know what I'm talking about. So, what is the shape of the sampling distribution of the random variable x bar, which represents the sample mean of the of the 81 students who are selected? According to the reading in the
Wouldn't it be normal?
yeah, according
According
to
to the reading from lesson 6?
Would it be approximately normal?
Approximately normal,
yeah, approximately normal.
Yeah.
It's also in the prep assignment for today,
Okay.
or at least in the reading for today.
So it would be approximately normal because
n is greater than 30.
Greater than 30, yeah.
Oh, right.
Right. So it's considered a large sample. Now, a large sample, you're going to have a normal.
And then our last lesson was if the mean was large, right?
No, it's the same thing.
It's still sample size,
Yeah.
Okay.
I believe.
Yeah, it was considered large, greater than 30.
Mm-hmm. Then less than 30 is where it became skewed.
Right.
Okay.
So we have number
11. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? Round your answer to 1 decimal place.
But I mean, isn't it the part of the question? Isn't it 3.5?
Yeah. Yeah, because the mean's the same either way. That's not changing.
Right.
I think it's just to test us and make sure we know what we're doing.
Oh.
All right. What is the standard deviation?
We're saying 3.5 for 11. Because the mean doesn't change. Okay.
Yes.
Okay.
So 12, what is the standard deviation? Round your answer to 3 decimal places. So for this one, we would do the 0.7 divided by 9. because that's the square root of 81, right?
Right. But divided by square root of 81.
So, and we're supposed to round to 3 decimal places, so I got 0.078.
78. Yeah.
Hold on. You lost me somewhere.
Alright. So, in the reading, to find the standard deviation, you do the standard deviation that they give.
Divided by the square root of 81,
Square root of n.
which is 9.
Mm-hmm.
Okay.
Of the sample size, yeah.
Okay.
Alright. So, everyone cool with number 12?
Yep.
I'm not yet, sorry.
That's alright.
It was the square root of,
The sample population, 81.
So you had 0.078?
Yes, sir.
Okay. I gotcha.
Alright. So, Rebecca, do you see the standard deviation that they gave of 0.7?
right,
Right, so that is theta. And in the formula to find standard deviation, you do theta divided by the square root of n. And so it would be theta, which is 0.7, divided by square root of 81, or 0.7 divided by 9.
the 0.078.
Yes. Alright, what is the probability that the mean for 81 randomly selected BYU Idaho students will be less than 3.3? Alright, this is another one of
Do
those
it
fun
again.
ones.
3.3 minus 3.5 divided by 0.7 divided by the square root of 81 again. So I got
Oh,
minus 2.571428. So
Yep.
now if we put that one in the applet, we come up with
0.0051? Or
yeah,
negative
0.005.
Yeah, run it to
Because
3 decimals.
this is the less than 3.3.
Yes.
So you have 0.010.
Sorry, was I talking?
No, we got 0.005.
I agree.
Oh, yeah. I accidentally clicked on the other side, too. Okay.
Alright, McKay, Rebecca, are you guys good with that?
The next question looks like really, yeah, because it's actually the difference. 2.1. This is greater than 3.3. I got 0.995.
That's what I got too.
What's in here?
Yep, I'm good.
Okay. And then for the last one, we're not supposed to use the information that they had given us previously. So, just as a reminder. Alright, number 15. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boat accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, more above or below the mean, than observed in this sample. Round your answer to 3 decimal places. Wait, if it is either above or below that sample, wouldn't it be 100%? Oh, no, because it's that area in between that we don't want. Okay.
So it's talking everything greater or less than 26.7 difference of the 185. Is that right? Am I not understanding that?
Sorry, guys, I kind of lost you. All right.
So here,
Can you guys hear me?
You're blocked, Chris.
Excuse me? Hey, guys, can you hear me?
yeah.
Yeah.
Okay. So what I got here is the same. So 177.6 minus 185 divided by 26.7 divided by the square root of the sample, which is 48. I got minus 1.920, which if we put in the output, I come up with 0.055.
That's what I got.
Okay. Sorry, I actually checked out for a minute for some reason. I don't know, my internet's there though.
It's all good.
So we're okay with 15. So we check number 4, come up with an agreement.
What did you get for 15? I'm still walking through it.
0.055. Is that right?
Yep.
Yeah.
Okay.
Okay, I'm good.
All right. Yeah. Should we head back to number 4 then?
Let's do it.
Yeah. Looking at it, it doesn't help after going through the quiz, at least for me.
So what's the verdict? I don't know. Personally, I don't think that we can determine.
Well, we do get 2 chances, right? So
Right.
I'm hoping that if we have to take it a second time, that the questions are all the same.
Oh, yeah. You're gonna be have to.
I think they are.
Yeah. Thanks, Rickshaw.
I think I could be wrong, but I think that 4 would be the individual observations.
Why do you say that?
I don't know how to explain it. I'm just going through some of the ones we did and figuring out what the standard deviation is in the different problems that we did. It seemed like had a smaller sampling size or smaller than the original.
Well, based off of what you just said, that it would be the distribution of sample means, right?
Oh yeah, sorry. Yes, the distribution
Okay.
of the sample, not the individual. Sorry. Yes.
Okay, I'd agree with that. I think that's true.
You guys want to change it?
Might as
Sure.
well, and if we get it wrong, we'll just.
Go back through and memorize all of our answers. Actually, I think I just memorized them all, so we're good. Alright, submit quiz.
Yeah. That's good.
Might as well.
Alright.
Hold on, it's taking a little bit.
Hey, we got number 4. Hey, what?
We got 5
number
wrong.
4 right, but we missed number 5.
Miss number 5.
Yeah, we got 16 out of 17.
So it wasn't central limit theorem.
No.
Oh.
What?
So
Wait. Oh, it's talking about the spread decreasing, which would be the law of large numbers, or no? I don't know. We could take that again, and my best guess would still be central limit theorem. I don't know which one that is.
I think it would be the law of large numbers.
That's the one that would make most sense to me too.
I don't know. Do we want to retake it and try law of large numbers, or do we want to just stick with 16 out of 17 and an almost 95%?
hold on, I'm trying to put it on. Yeah, it was.
Did you redo the quiz?
It was. Law of large numbers. More on that.
Bless you.
Thank you.
Christian, did you redo the quiz?
Did I lose you guys?
Chris?
Did I lose you guys? Oh,
Chris, can you hear us?
I lot of large numbers and I went through.
Okay, so you did it again.
Yeah, I don't know if he did the whole quiz or just that one question, though.
Can you guys hear me?
We can hear you. Can you hear us?
Doesn't sound like it now.
Hey guys, yeah, I put the law of large numbers and I went through
All right. Well,
100%.
all right. So it looks like the answers are the rest of the answers are the same. Do we want to go through it again?
I just wrote them down and I'm filling them out now, so
Yeah, that's what I did.
I can read them off if you guys need me to.
Okay.
All right. Give me a second to get back to it.
I'll start again.
All right. Number 3. I don't remember that answer.
0.175.
Oh, that's right. Number 4 is
Hey
distribution
guys,
of the
I'm not
sample
going to
means.
stop the broadcast.
Yeah, distribution sample means for 4.
5, law of large numbers.
You guys, I'm going to stop the broadcast. Is that okay?
Fine.
Yeah, that's fine.
Number 6.